Hello, my name's Brandon Polk. Um, I believe that the recent IPCC report is just rife with inaccuracies, and it's terrible science, I think. So, you get on YouTube and you hear all these people warning about a positive feedback is going to occur within the system, and that things are just going to spin out of control. And again, I think that's just absolutely terrible science. So I want to present what I think science actually does indicate about climate change. So um, I think the first thing that's important to understand is that the climate system, according to sound thermodynamic principles, will stabilize. So the principle I'm talking about specifically is called the maximum entropy production principle. It comes from the maximum entropy principle, which was espoused by A.T. Jaynes in, I believe, 1957, and I'll provide a link to the work in the description. But the point I want you to understand is that most climate scientists suggest that a positive feedback is going to occur in the climate system and make things spin out of control. What the maximum entropy production principle suggests is quite the opposite, that a negative feedback occurs in order to stabilize the system. Now, that might not be a state that's good for humanity, but we'll get to that. But I do want to point out that climate science is a real science, and those who deny the science of climate change, well, this video doesn't address that. But at the same time, I do want to point out how terrible many of the model predictions are, and how we really don't know what the future of the climate will be. So, all right. So, a thorough understanding of the second law of thermodynamics shows that over time, entropy is increased within the system until it reaches the maximum amount of entropy. Now, the second law of thermodynamics applies to closed systems, and in a closed system, that maximum entropy state is thermodynamic equilibrium. So the maximum entropy productions, or the maximum entropy state, and the thermodynamic equilibrium are the same in a closed system. Now, some have suggested that the second law of thermodynamics does not apply to open systems like the climate system, that, it's an open climate system and it has, inputs to it that prevent it from ever reaching thermodynamic equilibrium. And that's 100% true. But there are some principles that we can apply from closed systems to open systems, and that's what the maximum entropy production principle is. It's simply that in an open system, that the system will seek a state that has the maximum amount of entropy in it, given the constraints of the system. So an open system, like thermodynamic equilibrium, similar to, it can reach what's called a steady state, which is when the inputs are equal to the output of the system. So imagine, for example, you have an output that's 10 something. Well, the inputs could be 5 and 5 if you have two inputs, 6 and 4, 7 and 3, 7.5 and 2.5, or whatever. You could imagine there could be a million possibilities, an infinite amount of possibilities. So the point is that there are many possible steady states that an open system can take, but the maximum entropy principle is simply that the system will seek the state with the maximum amount of entropy in it. So this logically also implies that a negative feedback must occur within the system. And you can read more about that through Axel Kleidon, who produced this work. I'll be providing a link to that in the description too, but it was produced at the Max Planck Institute, which is a very well respected organization. So, all right. Um, so, understanding negative feedback, I think I've went over this mostly, but the one thing that I want you to really key in on is that the maximum entropy production principle implies that a negative feedback has to occur within the system at some point. Now, that stabilizes the system. That does not mean that the steady state that the system takes will be something that's good for humanity. It could be that increased global temperatures are the new normal. That is to say, that's how the system stabilizes, by having increased global temperatures. But it's also equally likely, well, I don't know how equally likely, but it is also likely that the system will cool down, that we will experience cooler temperatures so that the system stabilizes. Now you may wonder how that's possible, and that's what the next slide's about. Um, so, um, it all boils down to cloud coverage and cloud heights and clouds, and more clouds. I want to read something from the ISCPP, which is the International Satellite Cloud Climatology Project. It's by NASA. So again, I'll provide a link to them in the description too. But this is what NASA says, and so I just want to directly quote them there when it says. What makes it so important to disentangle the interaction of clouds and the climate? The balance between the absorbed solar radiation and emitted heat radiation sets the temperature of Earth. For example, when heat radiation from the surface slows, as caused by increasing greenhouse gas abundances, the balance can only be maintained if the temperature rises. Changing clouds can alter this relation, either increasing or decreasing the magnitude of the resulting temperature increases. Also, when clouds change, precipitation will change, which will affect the supply of fresh water to the land where we live and grow grow our food. Right now, we do not know how important the cloud radiative or cloud precipitation effects are, and cannot predict possible climate change accurately. And I've provided a link right here so you can read it yourself. But the point is that any model that doesn't include cloud coverage is probably wildly inaccurate. Um, and, the fact is we don't really know a lot about how much, cloud change relates to climate change. We don't know how much the clouds are changing. So, all these models, they're probably inaccurate. So, there's that. And really, I think what we can, the one thing that I think is important to understand is that increased cloud coverage results in cooler temperatures. So that's kind of obvious. If you get more sunlight that's bouncing off the clouds into space, not as much light reaches Earth, and you obviously get decreased temperatures as a result of that. So, are we getting increased cloud coverage? From as the Earth warms up, there is some evidence to suggest such. There is evidence to suggest that in the the ITCZ near the equator, that we're getting increased cloud coverage even as the global temperatures continue to warm. So the long and short of it is that there's a lot we just really don't know, and when scientists go on making alarmist claims that a positive feedback is going to occur and that the system is going to become more and more unstable, I think that's just pseudoscience. I mean, a firm understanding of thermodynamics, I think, logically implies that negative feedback has to occur in order to stabilize the system. So, um, that's the way I see it. I recommend scientists to come over here and show me where I'm wrong. But until such time, thanks everybody, and I'll be keeping on speaking the truth.